Lithium-ion batteries have dominated the last 2 decades, supporting the digital revolution by bringing electronic devices in our pockets and every household. And now it is expected to power our cars, or even to store our electricity for the green energy transition. By Elon Musk calling out the 4680 battery for Tesla by 2023, it seems like a major upgrade for the industry. But lithium, as a material, has been stretched out beyond its limits. Not only is it not an abundant material, but lithium-ion batteries also have significant disadvantages. When it's about recycling, environmental issues, charging time, and foremost, battery lifetime, it's not an ideal material for its mission. And now everyone is talking about a Mystic battery, which is not only supposed to last for a lifetime, but also never has to be recharged again. And what's more, it's made from nuclear waste, which we already have and produce in abundance anyway. So how does this Mystic nuclear battery work? Does it really keep the promises? And more importantly, would they really be able to replace the 4680 battery in the EV industry? Welcome to The Futurist. Join us as we explore these questions, and don't forget to subscribe to our channel to get updated on the world's development. Elon Musk introduced the 4680 battery in 2020 to set a major upgrade for the Tesla batteries, increasing the reach by 15% and decreasing the cost by 15% at the same time. That's definitely a big milestone accomplished by the billionaire. But Elon Musk also points out correctly that batteries are the biggest limiting factor for the EV industry. While the world's demand for electric cars have risen rapidly, lithium production, which is the main element used in today's batteries, can't meet the rising demand for electric cars. This lithium shortage has skyrocketed the price per metric ton from $6.125 in December 20 to $61.943 per metric ton in the year 2022. That's an insane price increase of 1,000%. This price increase for lithium as a raw material means also that the price for batteries and therefore electric cars will increase further in the long term, and that's not sustainable for the industry. However, lithium is luckily not the only material option for battery technology, and there is actually a company that recently made some headlines with their nuclear diamond batteries. They claim that these batteries should last 28,000 years and never have to be charged again. How is it possible to never charge a battery and supply whole generations with it? At the first moment, it sounds like a magical fairy tale stone. But the company NDB is really serious. The company NDB, which stands for Nano Diamond Battery, claims that their battery will be market-ready in just a few months. The concept behind it is based on the beta decay of the radioactive carbon isotope C14. It emits high-energy, fast electrons. Semiconductors like silicon can actually convert the beta decay radiation into electricity, and this is also known as beta voltaic. And there are actually prototypes and patents, so the concept really works. The University of Bristol has proved it years ago. Their prototype is already used in certain measurement devices for seismic activity, which has to be designed for continuous operation. That's impressive and promising, but also hard to believe that in a few months we'll be able to buy batteries which our grandchildren's of the 500th generation will still be able to use. So how do the batteries really work? And could they actually replace our lithium batteries like the 4680 battery? The breakthrough came in 2016, where the University of Bristol unveiled the world's first nuclear diamond battery, a battery made of waste from nuclear power plants. Graphite is used in nuclear power plants as a moderator. Here it is supposed to slow down the radiation of the nuclear fission process. However, exposure to it makes the graphite itself radioactive. Over the decades, large masses of this radioactive graphite have accumulated in nuclear power plants. The problem here is it has a half-life of 5,730 years, making it very difficult to recycle or dispose of. But a major component of this graphite is C14, a radioactive isotope of carbon that emits beta radiation. Ultimately, the perfect raw material for a beta voltaic battery. This carbon is further processed into a radioactive diamond, and coated with a protective layer with a non-radioactive diamond, for example. But how much power can such a battery supply? The public research on this topic shows that the performance of the battery is extremely low. We're talking about under a milliwatt. But that wouldn't be a problem either. If it stays that way, the system will mainly be used in special niches. Such a battery could be used in sensor technology, IoT devices, fire alarms, or pacemakers, where the battery has to be replaced every 5 to 7 years with a surgical operation. In just these areas alone, the battery is definitely a gigantic game changer. But what's really exciting for the majority of consumers is the statement of the startup NDB. In press releases and image videos, they claim that a 7-time higher energy yield is possible compared to conventional batteries. This would allow the battery to be used anywhere, from smartphones, laptops, even electric cars. Factoring in the long lifetime of the diamond nuclear battery, it turns out 56,966 times higher energy density compared to conventional lithium-ion batteries. In the context of these enormous numbers and the increased performance compared to conventional technology, the cooperation with renowned institutions such as the Lawrence Livermore National Laboratory was also mentioned. Although NDB names various areas of application for the nuclear diamond battery on the website, the actual specifications and properties of the batteries are not mentioned. For us, it seems a bit like they just listed every area where batteries are used for in general. And the 28,000-year term also sounds very ambitious. In principle, it is possible, albeit probably only a high loss of performance, or C14 replaced by another beta emitter. C14 has a half-life of 5,730 years. After this time, half of the material has decayed, which also reduces the overall radiation. The performance of the battery could accordingly decrease significantly over time in proportion to this. In relation to the short duration of a human life, this is of course negligible, but it shows that the company is quite generous with numbers. Nevertheless, the company's patents are very promising. That has to be said distinctly. However, it can't overshadow the problem that the company hasn't yet presented a single working prototype that lives up to the incredible reports, especially since the projected values are far above what other companies promise. The company Arcandlight plays an important role in this context. It is a startup that has emerged from the researchers at the University of Bristol, so they are the actual developers of the first nuclear diamond battery. Arcandlight's website lists clear products, their specifications, and even provides datasheets with information to download. None of the presented technologies are remotely suitable for end devices like smartphones or electric cars, and the manufacturer does not have this claim to the technology at all. The products are suitable for low-energy systems, so whether diamond nuclear batteries will really be able to power larger systems in the future remains doubtful, although it is not impossible either, because the technology is just in its infancy. It may also be possible that NDB is simply miles ahead of the competition. Either way, the influence of this battery technology shouldn't be underestimated, even on a small scale. Even if it doesn't become the battery of electric vehicles or smartphones, it may become the standard for smaller IoT devices in the near future. In relation to larger equipment, on the other hand, a newly developed graphene aluminum-ion battery is particularly interesting. It has a significantly higher capacity than conventional lithium-ion batteries and charges up to a whopping 70 times faster. It's also ready for the market. If you want to know more about it, click on the displayed video.